Hi, my name is Carlos, and my team is made of Soy Isabel, Brian Emmanuel, Dana Paola. The topic we are going to talk to you about is superficial quadratics. Today we have to define what a quadratic surface. Quadratic surface is the graph of a second degree equation that has the variables x and y and z. Thus being a three-dimensional figures figure having a general form ax2 plus by2 plus cc2 plus dxy plus axc plus fyc plus gx plus hy plus ec plus g equals 0. Being since the capital letters are all constants, this equation is difficult to manipulate, so it is derived into lasers once. These graphics are carried out in digital programs since their total extension can be seen into two-dimensional format. Quadratic surfaces are closed is having a center of Waldo a center. To stack have a canonical equation being to stack have a center such as the ellipsoid, hyperboloid, to set hyperboloid and the ellipsoid cone. How can we see on the screen? There are 6 basic types of quadratic surface. Los ellipsoid, elliptical cone, elliptical paraboloid, one sheet hyperboloid, two sheet hyperboloid, hyperboloid paraboloid.
Hello, my name is Brian, and today in this topic is the ellipsoid. And as its name says, it produces an ellipse within the three-dimensional planes. Science is derived from canonical equation. What is the canonical equation? The canonical equation is this: x squared a squared plus y squared b squared z squared and c squared equal to 1. But if you suffer an alteration any variable and it is equivalent to 0, a change in the graph produces cuts in the external axis on the variable, and all of these coefficients are positive and squared. Behind the sum of these products a unit. What if this? For example, x equal to 0 is the next equation. Y squared b squared plus z squared c squared equal to 1. This is the x equal to 0, the circle yellow. This is the curve in the ellipsoid. The next case is y equal to 0 is the next equation. X squared a squared plus z squared c squared equal to 1. And if this code y equal to 0, it is this code, the code blue. Z equal to 0 is the x squared a squared plus y squared b squared. And it is the ellipsoid. This is code is the x equal to 0, y equal to 0, and z equal to 0.
Hyperbole of a leaf. In the canonical equation is derived from the hyperbole equation. It has two positive coefficients and one negative. Unlike the previous one, TC produces unity. The variable that has the negative sign indicates on which axis the graph will happen. Its traces on the horizontal planes are ellipses, and on the vertical planes they are parabolas. The trace of the hyperbole and hyperbola in planes parallel to the xc and yc planes, while in planes parallel to the case c-axis. The fundamental difference between the hyperbole of a sheet and the ellipsoid is that it has a variable which has negative sign. Two-leaf hyperbole. This is very similar to the hyperbole equation of a suite, only it is with two negative variables and one positive, and also the product of third sum is 1 and the graph extends over the positive variable. Only in this case there is an exception. If the variable task has the positive sign, its equation to 0 and disappears. The equation has no solution. Its trace on the horizontal planes are ellipses, and on the vertical planes they are hyperboles. The traces of this surface are for planes parallel to xc. They are hyperbolas as well as for planes parallel to yc. It's different from the other surface since it has two negative variables.
Hello, in this topic is the elliptical cone. Within this equation are two components with the same sign and the different on one negatives, regardless the whether it is positive or negative. And after performing the relevant expression, it results to 0. is given as well as a result of a v on the equation above and below. The axis of the cone located in the variable, the opposite signs, and the traces of the horizontal plane are ellipses and of the vertical plane hyperbolas. For the center's quadratic surface, we see that the characteristic behaving to quadratic terms, but most always positive. It can also be observed that surface symmetrical with respect to linear variable in this category are included elliptic, parabolic, and hyperbolic paraboloid. And for example, one, in this equation is x equal to a equal plus I equal b plus squared, and the set squared is this. This is the parabolic cone of this equation. And for example 2, this is equation, and this is equation is this form. And finally, for example 3, in this form is the equation. Because the negative sign.
On the other hand, we have the centerless quadratic surfaces. These surfaces are different to others because in this case we only have one term and the other two variables are quadratic terms, with the linear term being to the sum of the quadratic product, and this product it has to be always be positive. If the result is negative, we have to multiply the equation for -1. It also can be the surface is symmetrical with respect to the linear terms. This category includes the elliptic parabolium and the hyperbolic parabolic. Meanwhile, the other parabolas are quadratic and positive. We will start with the elliptic parabolium. We can see that its equation has a linear term and the other two variables are positive, with the linear term that indicates in one of which the graph open. The paraboloid is located above the first great variable, a surface created by sliding a vertical parabole with the concavity down along together, perpendicular to the first. Horizontal sections are ellipses, while vertical sections are parabolas. As in the three examples that we have here, we can see that it doesn't matter which variable is the linear term. Meanwhile, the another two variables are positive, and meanwhile the other variables are quadratic and positive. The second one is the hyperbolic paraboloid. This surface is also known under the name Paisero or mountain pass because of its geometric conformation, as it is a surface that in one direction has the parabola-shaped section with the sides facing upwards and the perpendicular section. The sections are in the form of a parabola with the sides facing downwards. You can simply concept Paisero as a whirlwind. As we can see, there's not such a big difference between these equations with the other ones previously presented. But the difference between these and the others is that we can find that one quadratic term is negative and another one is positive. Also, the linear term is positive. And it doesn't matter which variable we choose to be the linear term. Just have to respect the equality that one quadratic term has to be negative. So as a little resume, we can say the next things about all the quadratic superficies that we saw on this video. The first one is that the ellipsoid comes from a quadratic equation, and if we have a variable equals to 0, it doesn't change the result of the sum of the terms. But we can see a little cut in this variable. The next one is that the hyperboloid has only one quadratic term, negative, and the result of this is equal 1. The third one is that the hyperbole of 2 leaves has 2 terms negative and 1 positive on the quadratic variables. Also, this negative term indicates where the graphic will be open. The third one is the 2-leaf hyperboloid. We could say that this equation has 2 negative terms and 1 positive on the quadratic terms, and it also has a result to 1. If we have any of these variables equal to 0, it won't affect the equation, but the graphic will be affected because we can see a cut in this one. Also, if we have only the 2 terms negative, there's no solution for that equation. Fourth is the elliptical cone, and we can see on the equation that the quadratic terms only have one variable negative, and the result of these equations is equal to 0. That represents a big difference between all the other equations that we see at the moment. Fifth, we have the hyperbolic parabola. As we can see in the equation, we have a linear term and the another 2 variables are quadratic terms. And all of these terms are positive. And finally, we have the hyperbolic paraboloid that also have a linear term, just with the difference that this equation has a negative term on the quadratic terms. It's important to remember that these last 2 surfaces are different to another ones because they are centerless surfaces. That means they have only a linear term and the other ones doesn't. All the terms that we can see are quadratics and a constant. and in these last two we only see quadratics and aligner terms.